Thank you for attending today's RDA webinar on data fabrics. I am Katrin Beck from the RDA Europe Training Program team. Now let me present you our speaker. After finishing his studies in electrical engineering at the Technical University of Berlin, with computer science and digital signal processing as main topics, Peter Wittenburg started working as a research assistant, setting up a center for control computation at his university. In 1976, he became head of the technical group at the newly founded Max Planck Institute for Psycholinguistics. In 2011, Peter became the head of the new unit called the Language Archive that was built as a collaboration between Max Planck Society, Berlin Brandenburg Academy of Sciences, and the Royal Dutch Academy of Sciences. Since 1988, he is member of the IT Advisory Board of Max Planck Society, has leading roles in European research and data infrastructure initiatives, and was member of the high-level expert group, which produced the Riding the Wave report on scientific data. So let's start our webinar. Peter?
Yep. Thanks, Katrin, for your nice introduction, and welcome also from me to this session, which is on data fabrics. We understand, I guess, that we are in times of dramatic changes. I just read another couple of papers about what we can assume for the next decade. And I think we all agree that data is one of the pillars of these revolutionary changes, which we kind of had of us. Now, what we are looking for, I guess, is that what is to look for, or what are the stable fundaments to be built on, so that we can realize or implement these changes in a way that we have still stable frameworks and not end up in Babylonian towers. So perhaps data fabrics can help a bit here, and that's what I'm trying to convey today. So I grabbed a few slides, old slides, to present this to you. And let me start with an overview. So I will speak about the data fabric concept as it started in RDA. I looked a bit into what the industry is saying about data fabrics. I then will talk about approaches to come to components, which will be essential elements in data fabrics. And I will just allude to a few components and relate them to the FAIR principles, which you probably all know. And finally, I will, if I have time, I will go to or briefly introduce two testbeds IDs and their relation to the European Open Science Law. So that's what I'm going to talk about. And for me, this all started after having made an interview in the years 2013, 2015, which we did in Europe, right? So we, as you can see, we interviewed 50 departments, experts from departments, and had even more community interactions. That means interaction with people from building research infrastructures and so forth, right? So about 125 interactions, which we had, very, very deep interactions partly. And of course, what we found out is not surprising, that all our work with data is much too inefficient, and especially if you start federating data, so using data beyond different silos, then it gets really costly to integrate the different data if you also include, for example, PIDs or metadata and so forth, right? Metadata of different types. So we concluded when we did this large work, we concluded that we are not ready for the challenges of the next decade, which are defined not only by what we know now in scientific data generation, but which will be defined mostly by all these new smart devices, which we summarize under the normal Internet of Things. So we are just at the beginning of understanding how much data and how complex data complex the data will be, which we have to deal with. Now, all I'm showing, or most of what I'm showing here, is going back to the discussions which we had in the Data Fabric Interest Group in RDA, and I should mention here that many colleagues contributed to these discussions, and I see that Alan is here. So Alan was one of the co-chairs together with me and a Chinese colleague. So from the very beginning. So hello, Alan. Nice that you are joining. So we did this together within RDA, and as I said, I grabbed a few old slides to start with, right? So one of the old slides is, of course, the question was addressing the question, what should we do? How to understand what's happening? Where can we perhaps change things towards more efficient procedures? And when we looked at all these different solutions, which we found in this overview, which I just spoke about, it reoccurs that everyone was busy with some identification scheme, at least when they did, more focused work on data. Everyone was busy with authentication, authorization solutions, with metadata, and so forth, right? So, of course, science and also in industry, there will be always specifics which have to do with the creation or the generation of scientific data. There will be even more maybe inspiring colleagues that invent new methods for sensors and so forth. And of course, also on the side of scientific analytics, there will be a huge amount of different solutions, which is good to work on the data. But what we thought is that in the middle, where you speak about data management, about data curation, about data access, about data formats and so forth, that in this area we can do a lot by reducing the heterogeneity which we currently have, the fragmentation, to a few, maybe to a reduced solution space. So that's where we started and where our hopes were. And and then let me go over to the image which showed the first data fabric. We even didn't call it the data fabric but when we saw this diagram, which looks a bit difficult, we thought about data fabric. There are a couple of steps which you could identify when you talk with all these different people, right? So, people got some raw data, did some pre-processing, have improved data, and then they did some curation. So they created metadata. They started to put the data in different file directory paths and so forth. So some organization of data, you could say, and then they did a step which I call now registration, to put these things in some stores so that they could start working. Of course, what we all know is, and this is still true, that most people just work with file systems within file system and use file systems, file directory structures as organization principles. And yes, people do metadata, but still mostly people do this with spreadsheets, as we all know. They are somewhere, and only the data creators know where they have these data. This is still current practice, I guess, and most institutions. And PIDs normally they didn't really exist; they were just some directory paths. So you got there was something like registration for all of them, but in a very primitive state. Not to blame anyone, since this is what we all did. Some people started to change the ways, so some people really started to work with persistent identifiers registered somewhere else, so not internally, and have metadata schemas, and started to register the concepts they were using, and so forth, right? Well, what you then see is that whatever people do with data, they start aggregating some data to build a collection. As said, mostly people still put data separately in some file structure, right? So a lot of copying takes place, and people start, sorting data into new file structures and then do some processing. And I guess you can all see here that here is a loop, right? So what people normally do is they aggregate certain data from their own silos, from different file paths, and then do some processing, create new data, and this story is repeating. So I hope you can see the loop. Some people, like in my domain, so the domain of language data, they even use publications for this cycle. So they take publications, electronic publications, of course, and also do some processing on this. So this is the first diagram which we discussed in the data fabric group, as far as I remember, and that already gives a bit of idea about the complexity behind this, especially if you think of data which is distributed in different repositories. What you also can see here is beyond this loop, which is down here, is that in red here, I should use that arrow. So in red, you see some indications. So at that time, when we started discussing this, we had 5 working groups in RDA, and you can see where they were busy. So the metadata group, for example, they worked on, how to systematize the work with metadata. So how to build catalogs of metadata schemas, which other people then can reuse and so forth, right? The BIT group, worked on, issues like, if we register PIDs, is there a generic API to a PID system, and so forth, right? I will not go to in detail here, but you can see that we started with 5 groups, I should say, and they all were kind of independent in RDA since when we started RDA, we had a lot of RDA working groups. We had a lot of pressure since in 18 months we should be ready and come up with some results. So all these groups worked hard on their issue with their views, and there was hardly no intensive interaction between these groups. Now, this then motivated us, and again I show one of the very first diagrams, motivated us to invite these 5 groups and some other groups to come together and talk about this data fabric. You remember the loop which I showed. To talk about this data fabric and see, and to better understand that we're all working on the same issues somehow, and that we need to understand what we are doing and to better understand each other. So we introduced in 2014 at the plenary, I can't recall, I should have looked it up, but I can't recall exactly which plenary. We started with the term, or we coined the term data fabric into the discussion. And we liked this term due to its ambiguity. So in Germany, fabric means factory, right? And as we know, in English, fabric means some kind of weaving. So we like this kind of ambiguity in this word. So we concluded that we should call our working group, our new interest group, in RDA, Data Fabric Interest Group. But of course, we needed to we need to describe what we mean with data fabric. Now, I grabbed again a few old slides where you can see some contributions. I will not go through them, that would be too much, but you can read them since the slides will be open. So we had a contribution, for example, from Reagan, who spoke more on the different phases of data fabrics. And we got a contribution from Beth, Plale, who looked more on the subject of automating processes and object tracking and things like this. Also very important issues. And of course, I contributed with my 2 cents to this early discussion. And I focused more on the digital object as core of what we are talking about. Well, finally, and Alan knows this, finally we agreed on 3 slides, basically. And I will briefly go through these slides. So the first slide was just concluding what we all agreed about. We're just beginning to scout out the landscape of data fabric. So we understood that we are at the beginning to study this cycle. In our view, it was data fabric is a minimalistic set of infrastructure and service requirements by which services can plug into the defined data fabric. In the data fabric, we ask how the separate components developed separately can be made to work together. This means that for different sets of components, the data fabric will be different, or will have a different look. So as you can see, we were in this group, we were very much against any prescriptive notion, which, for example, the term architecture comes along with. So we all didn't like the term architecture, since it's so often used, or also by IT people, to write down a certain group of blocks with arrows between them. So we didn't like this fixed way of how an architecture could look like. So we wanted to have something simple, something flexible, and where components played a major role. There's another slide which shows a bit what our main idea was. So it's again emphasizing this basic and flexible machinery that helps us to make data science reproducible, the common management and processing components and their relations, services, and interfaces. So again, the focus on components, general principles for the interaction between services, and of course the methods to allow people to register, integrate their digital objects into the machinery, and so forth, right? So we agreed on these kind of flexible kind of description of a data fabric as something flexible, where components, common components, specific components play the major role. And of course, as you can guess, we also had automatic workflows in our view. So this is described in one of our early descriptions. So we spoke about configurations, so not architectures, configurations. And you see components which are center, and different components depending on what you want to do. Do you want to build an infrastructure for management? Do you want to build a virtual research environment, or whatsoever? What kind of intention you have? You come up with different components and bind them together. We had, of course, the notion of common components, like persistent identifiers, like maybe schema registries or concept registries. So we thought that there will be some common components which will have a broad usage, and there may be also some specific components which come from disciplines. So this diagram, I think, led us in our further way of thinking. Now let me go over. So I try to bring over the basics of what we discussed in the data fabric interest group. And of course, there was a lot of discussion about components, and I will come to this in a moment. So if we all rely on components, what are they? How to come to them? And I will come to this in a moment. But first, let me briefly have a look into the notion of fabrics in industry. So one thing I found when I looked again the last days or so is that that during the whole grid movement, people started about fabrics, and you see on the right a diagram which I stole from the web, which indicates the kind of fabric. So it's kind of weaving. So the term fabric makes very much sense, and as I said, when I saw this, the first notion of the data fabric concept was together with grid computing fabrics, and later Cisco came or used that for unified data center fabric. But basically, they were arguing on networking aspects. So bring different repository system or storage systems, I should better say, bring them together by high-speed interconnects. In 2015, however, you saw from some visionary people, and you can look it up on the web. So I found something from 2015 on that you can see that what someone wrote here is not so far away from what we had in mind, right? So data fabric is emerging as an approach to help organizations better deal with fast-growing data, ever-changing application requirements, and distributed processing needs. So that comes already very close to what we had defined in the data fabric group. It gives even more, and then you really are in the ideas which we had, which we defined in the data fabric group, data from different systems. So data that have different organization principles below them. So like from SQL databases or no SQL databases, from file systems, cloud systems, or sensor streams, and so forth, right? So, and of course from different locations. So you see, this comes very close to what we discussed in data fabric. And when you then continue reading documents from industry, what you see is that they discuss now a transition from the old data warehouse concept to what they call data lake. Now, I try to understand what they mean. Data warehouse is a big structured repository. And what they meant is they first do all the mapping and so forth, and to put this into one data warehouse system where everything is already normalized. I hope it's clear what I mean. The term data lake was now introduced not so long ago. And what they mean, the industry people, is that, we can't rely anymore on this strict data warehouse approach, but we have to take whatever is out there. So from different storage systems, or different types of data and so forth. And then they call this data lake. So this is really what we are talking about in science as well. And as you can guess, for them, data fabric is a step of virtualization, right? Virtualize away from the different organizations of data, from the different types of data, and so forth. So not so far away, but I had many talks now with industry people during the last months. I must say, the notion of data lake is fairly new to most of them, since they still like to work in a data warehouse, where they have a controlled environment, which makes very much sense, since then they know how, then they can influence the speed of operations and, of course, be very efficient. Let me see. So what I also did was a brief comparison. What the term data fabric means in industry in the current discussion, and what we meant with this. I see a note from Wouter Edding. Yes, Wouter, that's true. I hope I expressed it in the right way, right? So what you said is exactly what I wanted to express as well. Thanks. So I should. There's an error in this slide. So this should be not 2007, but more 2015 or so. So when you look, we both speak about distributed data. We all speak about all data, taking all data, as just Wouter mentioned in his chat. So including all kinds of data, all types of data. Industry still hopes on one big fast store. So first to bring it all to a cloud system or whatsoever to store all these things independent of the different organization and types. While we didn't speak about this. There may be different opinions in the industry. I'm not so sure about this, but when you read the articles, they still hope that they can put all this into a controlled environment. It's digital object centers in our notion, while the industry doesn't have that notion. And of course, close to our thoughts about digital objects, we thought about the global PID system, which gives all such objects an identification, and this is also not being discussed in industry at this moment. And of course, when we make a difference, if you look to the models of digital objects, we make a difference between metadata and data. In the industry, you don't find this. If you read these articles about data fabrics, they don't make this difference so explicitly. And of course, they speak about adapters to the different protocols and so forth, while we hope that we have kind of unified interface for digital objects. Of course, we both speak about virtualization concept, And we spoke about or integrated the life cycle view, while you see in industry this is not really such a big problem at this very moment. So that may give a bit of relationship between what you can find, or what at least I found in the industry from the discussions and on the web, and what we discussed in RDA. Now, let me go over then to the approaches, how to come to components. And of course, different views are so important, right? You cannot come to components just by following one view. So I will just briefly give you a couple of ideas how to come to components, and also inform you then what kind of diagrams we used in the data fabric group. So one diagram is certainly interesting, when you start from the Internet Analogon, right? So if you imagine that you have devices in the internet, they exchange meaningless from our side in general, meaningless messages, right? So some chopped stuff, chopped stuff, and self-routing between internet devices, right? So that's really doesn't these messages don't have a meaning, for example, for science. Well, on the other side, they are kind of chopped from data centers, and they are reassembled at other data centers. So what are these data centers exchanging? Well, if you don't accept the word digital objects, you could say they exchange files or whatsoever. Of course, we use in data fabric, we use very much the term digital objects. What we say is they exchange digital objects. They talk about digital objects, and they're identified by PIDs. And of course, these digital objects are meaningful data entities. So I'm not speaking about granulation, as we did recently in a working group in a European project. I'm not speaking about versioning and so forth, all these things, but just saying digital objects are meaningful data entities, meaningful for the scientists. They want to address them, they want to talk about them, they want to process them, and so forth. And what you hope is then that we can build a digital object interface protocol that on this level, that of course will make use at a certain moment from messages exchanging on the internet level. So we use this, to come to certain components like the digital object interface protocol, like the PID, and like repositories, and so forth, right? So that's one view to come to components. Another view was introduced very early by Larry Lannom, basically already in 2012, before RDA started. In fact, this diagram kicked a lot of thinking within RDA. So Larry spoke about these different steps, which very much look like the FAIR steps, right? The FAIR principle steps. So discovery, FAIR talks about finding, which has a bit more like discovery in it, about access, interpretation, and reuse. So if you replace discovery by finding, then you are already with the FAIR principles, or the FAIR layers of principles, I should better say. So that's also something where we which stimulated component finding. Well, when you discuss discovery, of course, you immediately come to metadata. You immediately come to metadata catalogs of schemas, right? You immediately come to registration of metadata elements so that other people can use these information for interpretation and reuse purposes. So there was another view already introduced in 2012, which I think we all like very much, and which was continually used in the data fabric group. Of course, another motivation is this more classical data lifecycle program, right? And I will not go through all the steps here, but you could immediately see that, when you describe data, for example, when you're here at this phase, you want to describe it by metadata. You want to have a schema, and so forth. So things I just started to say before. But when you come to preserving data, you might want to add other bits of metadata. So you see in this cycle, for example, where at different moments in time, you would like to add different types of metadata to your metadata stack, right? So, and it also indicates already that, when you analyze data, you should have more metadata and so forth, right? So this was also a good source or inspiration for thinking about components. Well, the last one is, I think, the most used diagram in the data fabric. We had different versions of it, but basically, if you think of my third or fourth diagram, which was this complex diagram, it's now very much abstracted and simplified. So what it says basically, well, you have some sensors or simulations or crowdsourcing, well, whatever, some ways to create data, generate new data. You form a collection, whatever you do, however you do it, you organize it a bit, and then you register it in some repository. And registration includes, kind of PID and persistent identifier if you do it good, well, and so forth, and have a way to store metadata and data in a certain way so that they are linked with each other. Of course, then you build, if you want to do some processing, you want to build a new collection, you pull out data from, so I should better say here, digital objects from different repositories, maybe, so in a distributed world, build a collection, which nothing else than a bit of metadata again, structured metadata, which has a lot of pointers, and then start your processing, right? And that will create new data, which you again store in the repository, and so forth and so forth. So this is the machinery which you often has, and of course people repeat certain steps since they were not successful, and all this what we know from the data labs. At a certain moment, you would like to extract knowledge from a collection and publish it, and together with some data. So you want to cite that data which is in the repositories. So this is a more abstract way of showing this very initial complex diagram, since data cleaning and so forth could also be seen as a kind of processing step. So that's a processing step. That's another stimulus for. There was another stimulus for our work in the data fabric, and I will later come back to this diagram. I should also mention, of course, the discussion which we had together with the brokering people in RDA about data processing. I will be very short. I will be very short here, since I will also come back to this diagram. The main point is that some of us argued that we get so much data that we need a structured data market, right? A data market, or whatever we call it. However it's organized, where people just add data, where repositories just show us that they have new data, and where we have agents, that screen the market and see, is there something new for my processes, so that you can start then the processes. So that's again very abstract formulation, but it was also a stimulus for us to think about components. I will come back to this diagram later as well. Okay, so recently, so during the last year, I found out that there is a lot of work on reference architectures. This work mainly comes from industry. And of course, the purpose is, behind all these reference architectures is how can we ensure investments, right? That's one of the main, interests of industry, of course. How can we come to components or blocks or whatever we call them that have a chance to survive, and so that the investments that have been done are profitable. So I will not go into the details of this specific reference architecture. It's taken from the industrial data space, and it's all on the web. And if you look at this, of course, it's only just one view. They have other views dependent on the roles you take, right? So you have consumers, you have creators, and so forth, and you find all this. So very well done. And when you go for reference architectures, you will see that there's more out there. So the Industrial Internet Consortium in the US, mainly in the US, has created, has come to similar ideas. You could say it's a bit more top-down approach that people think what's the whole landscape. Start of course first with terminology definition, conceptualization, and come to these kind of diagrams. And you see also in Germany, you have the Industry 4.0 initiative, which is a very broad initiative. And also they came up with such a reference architecture, which is called RAMI. So it is worth to look at them and also use them as inspiration. I looked at, especially at this at the work from our colleagues from the industrial data space, and I found a new motivation for the big role brokers will have in the future, right? So I underestimated the term broker here, but when you read this industrial data space of reference architecture, you get an idea what how relevant the brokers will be in future. So that's another stimulus for thinking about how to come to components. I added another bit of information here, which results from the many discussions I had with industry people, and this it's inspired by trading requirements. So industry people want to know exactly where their data is, what the usage scenario is, and whether people behave according to these contracts. So you see, they make a difference, or would like to make a difference between, well, identification somehow, metadata, data, transactions that describe what has happened. So whether a certain piece of data has moved to someone else, and of course, with the transaction, they have smart contracts which define the type of usage. So that could also be an inspiration, for us to come to components. So this, for example, all this reading and the interaction with the industry made me convinced that some kind of blockchaining will be necessary and as a very safe and highly protected piece of information that covers all the transaction. The question is, of course, how do you combine such a method like blockchain or whatever it will be with the normal work in the labs when people start analyzing this, right? So this will be a big question then. But anyhow, also this diagram, or reading this and looking at the differences between these different information types, it helps stimulating thinking about components. So that's enough about approaches to come to components. And now let me briefly come to some components and what we did in the data fabric interest group. We still have, we have 40 minutes, so I should move up. So here I come back to my diagram, which you can see, and of course you can immediately start fantasizing about a huge number of components, right? So if you have repositories, if you talk about repositories, you will immediately talk about repository certification, since you need trust building. You will speak about repository systems. You will speak about a registry of trustworthy repositories, and so forth. So I will not go through all these. You can see it and on the slides later. But such a diagram immediately brings you to components which are required or will be required, especially when we think that we have thousands of repositories, which probably will all, or many of them will get some certification. Well, you have to have a registry so that people can find them and see what kind of services they offer, and so forth, right? So you see here that, and of course, metadata is a big issue, and collection building immediately brings you to the idea we need a collection builder working in a distributed scenario, and so forth, right? So you can see here on this diagram that this diagram simulates component building. Of course, we have a lot of components already there. Probably we need to have a more systematic approach And you can also imagine that RDA is working on a number of these issues which are shown here, especially if you look to a repository registry. There was an approach, it was not yet continued. People speak about the repository system. People, RDA groups worked on the repository certification and came up with very good results. So this has been done, and you see quite a number of components which are partly there, partly have to be systematized, and partly have to be developed. So here's a list also of components, which is an old slide from I think 2014 or so, 2015, where we listed down, the different types of components, and I don't have to go in detail again anymore. So you see quite a number of things. For example, like an authorization system, a registry for authorization information, which we still don't have, right? Things like this, right? So you will find this here. And of course, there are metadata components. Also, of course, that's not surprising, we came to the need to have registries for our semantic categories. Some have them, many not. But mostly, this is not has not been done in a systematic fashion. Everyone does it differently, and it's hard to find them on the web. The same holds for vocabularies, right? Of course. So, yes, I already mentioned the need to come to, when we already have some solution, to systematic approaches, and probably need to reduce the solution space, right? To come to a maintainable ecosystem of infrastructures. So here I then want to discuss briefly. Let me check the time. I should finish. So I wanted to briefly point to some components and just have I think have two cases or so. You see what one group in the data in the RDA research data alliance came up with. So it's a model, a core model, as we call it, from what a digital object is. Sorry, it has some bit sequences. It has a PID, and it has metadata. And so this diagram is a simplified diagram of what we came up with. Right? So the final diagram is a bit more complicated, but the core is this. And of course, it has some bit sequences, which is stored in some repositories. And what you can see here is a collection is also a digital object, right? So it has a PID and it has metadata. Well, if we would all follow this model, this very simple model, then we would already get a huge amount of harmonization. So when we, in another big project in Europe, made replication of data, we found, of course, that metadata is hidden in different databases, sometimes hidden in scripts and so forth, right? So it's not a digital object. And that's, of course, that creates a lot of problems and is not maintainable. So if we all would follow this kind of simple model, we would already have gained a lot. And there's quite some work to be done. And here's another small diagram related to this. So some people believe in this, others may not. If we believe that the persistent identifier is persistent, and we have to take care, we as community have to take care that this really is persistent. And then, we agreed, many people agreed that we can associate with a PID some relevant information. So where are all the copies of the data stored? We know of. Where's the metadata or the provenance record? Where's the rights record? Where's maybe the transaction chain, right? So where can we find information for this digital object about the transaction? And of course, you could add checksum to always identify whether we still speak about the same digital object. So this has been done in data research data alliance. People are working on this, and especially on normalizing, let me say this, come up with a core set of elements which our colleagues in RDA call the kernel information types. So this is going on in RDA and very important. So last testbeds, just A few comments and then I will finish. So some people in RDA who work now in the data fabric group, they came to a conviction which we call global digital object cloud. We don't like the term anymore since the term cloud is completely overused and we don't like it anymore. But anyhow, what it specifies is that if you have users here on the left side, I should use that arrow. If you have users on the left side, so some clients here, they only should work on the on the level with logical information, so PIDs and metadata basically, right? And make their collections and start some orchestration of workflows and then execute their collection. And of course, these things are delivered by registries and repositories, what have you. So some instances here, some services which are given by probably a large number of service providers. And on the notebook desk, you probably have a button which says, "Oh, there's a service from the language people, and there's a service from the astronomers." However, this is done so that you can work with the digital objects. So the users just see the services from these guys and don't know anything anymore about how it's stored, whether it's a file system, whether it's a cloud or whatsoever, or a database. That's left then over to the interfaces between these two layers. So this is something we're working now on. This is all based on the discussions which we had in the data fabric group. And so there's a group of people, as I said, that wants now to implement this, and the specifications of this landscape are going on. And I'm really optimistic that we will be able to do something rather soon. I will skip that and just show that, we're not we don't have to start from scratch. Of course, there's much knowledge around. There are metadata schemes. I will not go on to this. Let me just refer to one system, which is, of course, core for all what we are doing. So this group of people which work on digital object-centric solutions, which is global handle system for PIDs. And we are all, or the group of people who came together, we all using handles, and the handles also from the digital object identifiers, which are also handles. They have a slightly different, or they have a specific business system together with the handles, why they call it digital object identifier. But anyhow, it's these identifiers are protocol independent, and they are resolved to state information which can be used, which means that not only the PID has to be persistent, but also the resolution system has to be persistent. If the PIDs are nicely specified, then of course everyone else could start building another resolution system. So what it mainly does is you don't address from the client your objects directly. You go to a PID. The PID comes with state information, as we call it. One state of information is where the different copies of your data can be found. Well, the good thing is that there is now a global foundation that takes care of the handle system. And you see there are currently 10 so-called root resolvers, which building on redundant schemes. So if one resolver is out of business, the others will take over. So it's kind of stable, reliable system now. And currently we have 10 such MPAs, as we call them. And next year, I think we will have 12. So that's a great start. And there's a DONA Foundation registered in Switzerland, in Geneva, and the DONA Foundation, where you have people from different regions and continents involved. They have the task, or the DONA Foundation has the task to guide the system and to make it stable over the years. And you see, we have these root resolvers in many different countries. Of course, US, you have them in China, you have them in Germany, you have the International DOI Foundation involved. Russia, South Africa, and I think Arabia, Saudi Arabia, and so forth, right? So a lot of things, and these registration authorities at this moment also give them rights to service providers as DataSite, where you can get DOIs, or EPIC, where you can get normal handles. So RDA is the handle system is global, which gives us, I think, a good basis to continue with our thoughts. And I think no, last slide, just to make the relation to the EOSC. I think the EOSC, those people who are in Europe, you know this. The European Open Science Cloud is just another impulse to come to this ecosystem of infrastructures. That's my simplified view. And of course, it has to be based on the FAIR principles. FAIR principles are not a blueprint to design infrastructures, but it's good, there are criteria to see whether a certain infrastructure will make its way or not. It all goes back to what a group of people described in 2010 or 11 in this blue booklet, Riding the Wave, where we came up with this diagram where you have common data services, where you have discipline-oriented data service, and so forth, right? And basically, this describes a bit, that was one of the first diagrams, describes the ecosystem of infrastructures where you're looking at. And as said, European Open Science Law is a great initiative in Europe to, give another impulse to do this. And of course, it's an utterly complex enterprise. No one size fits all. So there will be different solutions in these layers, which is important. There will be different repositories, types of repositories. And we have discussions, how far this whole enterprise should be bottom up or top down, whether we need reference architectures or just start with components, whether we have domain science driven, so having scientific cases driving this, or whether it's IT driven. What we believe is, so the group of people whom I represent as well, is that RDA is a good base to simulate components building. There are others like Open Archives initiatives, World Wide Web Consortium, and so forth. That we probably not just need one testbed, but what we need several testbeds. And that's what we're starting now as one of these, I think, nice testbeds, which we should have under European Open Science Cloud. Well, I'm a bit out of my time. Sorry for this. Thanks for your attention. And here's a bunch, at the last slide, there's a bunch of references which you can look at and find. And of course, if you have problems or questions later or comments, I'm happy to take them. So thanks a lot. And